Hey, 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 it's our Unit 2 review party! Up first, we're identifying the hypothesis, we'll put it in red, and the conclusion, we'll put in green. All right, of each statement. So the first statement says, if a polygon has 5 sides. So the if part, the part right after if, a polygon has 5 sides, is the hypothesis. And the conclusion is what follows. Then it's a pentagon. So it is a pentagon is the conclusion. Cool, cool. And symbolically, that's the P and the Q. So whenever we talk about symbols, the hypothesis is the P and the conclusion comes after it, so it's the Q. All right, in the next statement, if two angles form a linear pair. So the two angles form a linear pair, that's our hypothesis. If that happens, then the conclusion will follow. Then their non-common sides form opposite rays. So there's our hypothesis and conclusion, and symbolically, P is our hypothesis and Q is our conclusion. Very cool. Up next, we're going to write as biconditionals. And biconditionals use the magic word, or the magic phrase, if and only if. We can write biconditionals if both the conditional statement and the converse are true. So, speaking of that, this statement, we have a conditional statement, a P, then Q. So we have our good old conditional statement. And then we have our converse, Q, then P. So like I said, if both of those are true, we can write a good definition using a biconditional. So in symbolically, that would look like, oh snap. Symbolically, that would look like P with an arrow going both ways, Q. Because that means that the statement could be true going both ways. All right, all right. So the next one, we actually have words. If two lines are perpendicular, then they meet to form right angles. And then it's converse. If two lines meet to form right angles, then they are perpendicular. So they're both true. So since both the conditional and the converse are true, we can write a good biconditional. So our biconditional is going to start with the hypothesis. And our hypothesis is if two lines are perpendicular. Or I guess writing the biconditional, it will just say two lines are perpendicular. Then we'll use the magic words if and only if. And then the conclusion. Wow, words is hard. So the hypothesis was two lines are perpendicular, if and only if, and now the conclusion, they meet to form right angles. Cool, so that is like the perfect definition, and that's why we did this. We talked about biconditionals so we could talk about good definitions, and that's a good one for perpendicular lines. All right, up next, what do we got? Use the following conditional, write its converse, inverse, and contrapositive. Okay, so it starts with, just like all the others, it starts with a hypothesis, the P, and the conclusion, Q. And then they ask us to write several things. The first one is a converse. So with a converse, that's where we want to take the P and the Q and flip them, because if you're wearing Converse shoes, you can do flips. So the converse flips the statement. All right, so I'm going to take the P and the Q and flip it. I'm even going to write it symbolically. Instead of P then Q, it's going to be Q then P. Okay, so our converse is going to be if angle Y is a straight angle, then the measure of angle Y equals 180 degrees. All right, so you see how we flipped it there. Now the converse flips. Now the inverse is going to do something a little different. The inverse negates. That's the magic word for this one, negates. So negate is going to say the opposite of each piece. It's not going to flip the whole thing around. It's going to say the opposite of P, then the opposite of Q. So it doesn't flip the statement, it just makes each piece opposite, negates. So instead of saying if the measure of angle Y equals 180, we're going to say if the measure of angle Y doesn't equal 180 degrees. So that little symbol means doesn't equal 180 degrees, comma, then angle Y is not a straight angle. Okay, so that's what it means to negate. We're saying the opposite of each piece, not flipping the statement, just saying the opposite of each piece. Now the contrapositive does both. It flips and negates. So it's a fun one. So it does both. So the symbols for this one is going to be, it's going to negate it and it's going to flip it. So it's going to be a squiggly Q, squiggly P. So it's going to read if angle Y is not a straight angle. Then the measure of angle Y does not equal 180 degrees. So it does both, right? Gets crazy. The next part's not too bad. We're going to negate. So that is the squiggly. We're going to negate it, so we're going to say the opposite of each piece. So when you think negate, the symbol is a squiggly. The angle is obtuse. No, it's not. We'll negate it by saying the angle is not obtuse. Okay. Up next, the circle is not a polygon, so we'll negate it by saying the circle is a polygon. So just saying the opposite of whatever they say. It's kind of like being married. Q. Well, the negation of Q would be squiggly Q. Negates it, says the opposite. Ooh, last one's a little tricky. Look at that, it's a squiggly P. So if we squiggle a squiggle, it cancels out, right? So just a regular P, because it was already squiggly. All right, guys, so there's 1 through 3. I think we got a couple more. We got time for more. Number 4, using the following statement, give the truth value. All right, if 3 points are collinear, then they are coplanar. And that is true. If 3 points are on the same line, then they must be on the same plane. So the original statement is true. We had our hypothesis, conclusion, and it's true. If 3 points are on a line, there you go. They're going to be on the same plane. All right. Let's look at the converse. Remember, the converse flips the statement around. So the converse, the symbol for it is Q to P. So if I flip that statement, that's going to say if they are coplanar, then the 3 points are collinear. So let's draw a picture of that. I know I didn't write it because it's a lot of words. But if they are coplanar, so let's draw 3 coplanar points, then 3 points are collinear. And that's not necessarily true. Just because the 3 points are coplanar doesn't really mean that they're going to be collinear. So I'm going to go with false, or not necessarily true. Okay, and the reason is that red picture. Up next, the inverse, which is squiggly P, squiggly Q. Now there's 2 ways to do this. Number 1, you could actually write the inverse and see whether it's true or false. Or you could understand that the converse and inverse are related to each other. And if the converse is false, then the inverse must also be false. So shortcut, the converse is false, the inverse is also false. But we can take a look at it anyway. If 3 points are not collinear, then they are not coplanar. Well, look at this picture. It's the same picture. 3 points that are not collinear, they're still going to be coplanar. Any 3 points would be coplanar because 3 points define a plane. So it is false. And last up, we got the contrapositive. Now there is a shortcut because the contrapositive and the original conditional statement are going to be equivalent. So if the original is true, the contrapositive is always true as well. And we saw that when we did our notes for this section. We had our 4 things, and we talked about how the conditional and the contrapositive were going to be true, or, we're going to be equivalent. And we talked about how the converse and inverse were going to be equivalent as well. So that's where we saw that in our notes. All right, cool. Moving on. Inductive or deductive. So inductive was our patterns, which you guys didn't like as much as I thought you would. And deductive was our laws, which you guys did pretty well with. So we need to look at these statements and see, do these statements talk about identifying a pattern, or do these statements follow a law? And for our laws, we only had 2. We had our law of detachment, and we had our law of syllogisms. So let's see what we got here. All photosynthetic organisms produce oxygen. Okay. Phytoplankton are synthetic organisms, so they produce oxygen. Cool. Well, that's going to be one of our laws. So therefore, that's going to be deductive reasoning. Let's talk about which law. Because this gives me a conditional statement, it gives me a P then Q. If it is a photosynthetic organism, then it produces oxygen. And then it tells me that phytoplankton makes this true. Phytoplankton is a photosynthetic organism. So if P is true, then Q must follow. That's our law of detachment. So yeah, it's deductive reasoning, but specifically, it's the law of detachment. So that's anytime you have a if-then statement or something like that, and the first part is true, the second part must follow. That's like when I said, if you have dreadlocks, then you listen to reggae music. My mom's got dreadlocks, so you know what that means. Law of detachment. She listens to reggae music. Okay. If you are a redneck, then you drive a truck. Well, my dad's a redneck. He drives a truck. It's true. He listens to Joe Diffie. Yep. All right. Now you know all about my family. Each week for the last 6 weeks, my grocery. Each week. So this is something that happens repetitively. Each week for the last 6 weeks, my grocery bill has been 10% higher than the week before. So then we're making a conclusion based on that observation, that pattern. Okay, we see a pattern. Pattern alert. Pattern alert. So that we know because of that pattern that this must be inductive reasoning. Can't spell. All right. Cool. This video is becoming longer than I planned. A couple more problems though. All right. Using the law of syllogism to write a logical conclusion for the argument. Okay, we got this. This is where law of syllogisms links things together. It says, if this happens, then this happens. And if that thing happens, then something else is going to happen. So if the first thing happens, then, well, that's too confusing. Let's make this a little more simple. If I play guitar, then I'll join a band. If I join a band, then I'll go on tour. So the law of syllogism says, hey, if this first thing happens, then ultimately the last thing is going to happen because the middle one is going to link the two together. So for that to happen, boo-boo. So I could say if I play guitar, then I'll go on tour. Because this middle thing links the two statements together. But for that to happen, the middle part has to be the same. Symbolically, this would be written as, well, I got a P to Q, and then I've got a Q to R, just a different letter. So see how the middle part is the same? So that means if P happens, somewhere down the line, later on, R is going to happen. Okay? That's the law of syllogism. If you read the book, If You Give a Mouse a Cookie, that whole book is a syllogism. All right? So this one says, if a figure is a triangle, then it's a polygon. So there's our first statement, and then here's our second statement. So P, then Q. If a figure's a triangle, then it's a polygon. And this re-says that Q statement. If it's a polygon, then it's a closed figure. So we have a new statement. Let's give it a new letter. How about R? So this says if a figure is a triangle, then it's a polygon. If it's a polygon, then it's a closed figure. So the logical jump we can do there is say, hey, if it's a triangle, it must be a closed figure. So our conclusion would be, oh, not that. If a figure is a triangle, then the last thing is going to happen. Then it's a closed figure. Cool, cool. All right, so there's your law of syllogism. Up next is the law of detachment. Remember, that says that if you have a statement P to Q, and then P actually happens, becomes true, then Q is going to happen also. So if two angles have the same measure, so here's the P, then they are congruent, Q. Hey, look, I have two angles that have the same measure. The measure of angle A is equal to the measure of B. So P is true, check. So if P is true, then Q is going to have to be true as well. So since the measure of angle A is equal to the measure of angle B, then they must be congruent. So then angle A must be congruent to angle B. All right, and if you remember from what we did last week, that's our definition of congruent angles, or definition of congruence. Okay, so you're definitely going to use that again. And our last one for this part, write yes or no to indicate whether the following conclusions can be made from the figure. This is all about getting catfished. Don't get catfished. F is the midpoint of EG. F is the midpoint. I would only know that if I saw the tick marks there. I don't see the tick marks. There's nothing to identify if F is actually the midpoint. So I'm going to go with no because I can't say for sure that that's true. All right. BD is perpendicular to AH. So for it to be perpendicular, I got to see the magical symbol. So BD perpendicular to AH. And that's just not true. For it to be perpendicular, I would have to see a 90-degree angle there. So there's no 90-degree angle, so I can't identify if that's true or not. Up next, BCA. So find the measure of BC. Where's BCA? BCA. So this angle here. plus angle ACD. Okay. Ooh, look at those two angles together. Equals 180 degrees. Now for this one, I can say yes, because I can see that those two angles together form a linear pair, which is supplementary, which means it equals 180 degrees. Cool, cool. And then last up, points E, F, G, and H are collinear. E, F, G, and H. And you know that's a no. All right. So a couple of things that could have been added to this figure. We could have talked about the fact that line EG was perpendicular to AH. Okay, they didn't ask about it, but it's true that line EG is perpendicular to line AH. That's about all that we could have said. We could have said that A, C, F, and H are all collinear. That would have been cool. All right, but we couldn't say anything about the midpoints because I didn't see any of those tick marks there. Now, if they would have showed me tick marks between EF and FG, then that's when I could have said that F is the midpoint. But it didn't say that. I didn't have those markings there. All right, this became a 20-minute video. I'm sorry. Bye.